Ya, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi. Okay, kita sambung lagi pelajaran kita dalam Applications of Differentiations. Kali ini kita akan sentuh berkenaan dengan topik 6.7 Rate of Change. InsyaAllah dalam video ni saya akan tunjukkan 3 contoh contoh problem yang berbeza berkaitan dengan rate of change. Sebelum kita pergi kepada example, suka saya ingatkan sedikit konsep berkenaan dengan rate of change. Contohnya benda yang common terlibat dalam rate of change is contohnya dekat sini kita ada ketinggian ataupun it is denoted by h, dan let's say that we would like to find the rate of change of height or a level of the height of the certain cases. Okay, so normally kita akan tulis dia sebagai dh over dt, ataupun kita panggil dia dekat sini, kita nak tengok kadar perubahan ketinggian terhadap masa. Okay, so dalam matematik kita tulis dia sebagai dh over dt, ataupun erti kata lain sebelum ni saya ada mention dalam kelas, dh dt bermaksud we differentiate h with respect to t. The same thing if for radius, let's say that we have radius dan kita nak tengok kadar perubahan radius tersebut terhadap masa, kita akan tulis dr over dt, ataupun kita panggil dia sebagai differentiate r with respect to t. And we also have a case of area, okay, which is denoted by a, dan jika kita ingin melihat kadar perubahan area terhadap masa, juga kita akan tulis dA over dt. And also we have a volume cases, okay, which is denoted by v, okay, volume. And untuk kita tengok perubahan volume terhadap masa, kita akan tulis dv over dt, ataupun kita baca dia sebagai we differentiate v with respect to t, right? Okay, so dalam rate of change, konsep yang kita akan guna pakai untuk menyelesaikan masalah rate of change adalah, it's a common thing is kita akan guna kaedah chain rule. Okay, chain rule, di mana dalam konsep chain rule ni, kalau pelajar-pelajar masih ingat, kita akan gunakan let's say kita nak dapatkan dy over dx by chain rule. If let's say we have a parameter t, so this will be equivalent to dy over dt times dt over dx. Okay, so yang ini adalah merupakan konsep chain rule yang kita akan guna pakai untuk menyelesaikan masalah rate of change. Okay, baik, kita continue dengan example 1. Okay, example 1. A cylindrical tank has a base with radius r 2 meter. The tank is filled with water at the rate 2 meter cube per minute. Find the rate of change of the water level in the tank at any instance. So from these questions, kita nak dapatkan the rate of change of the water level. Okay, so sebelum kita sentuh soalan ni, saya ada lukis gambar rajah cylindrical tank dekat sini. So illustrated the problem of example 1. Okay, seperti mana kita tahu, so this is actually ketinggian of water level, it is denoted by h, dan kita ada radius dekat sini, dekat base dia. Alright, radius. And of course kita nak kena tahu satu lagi adalah volume untuk cylindrical. Okay, so volume untuk cylindrical, yang ini you boleh refer dalam internet, normally dalam exam it is provided if ada soalan yang berkaitan dengan cylindrical tank problem. So volume for cylindrical is pi r square h. Okay, so this is actually a formula to find volume for cylindrical. Alright, so this information yang kita perlu tahu lah sebelum kita mula soalan ni. Dan seterusnya dekat sini kita nak rate of change of the water level. So bermaksud kita nak melihat kadar perubahan sukatan air. Bermaksud kita nak kena tengok perubahan ketinggian level air di dalam tank tersebut. So bermaksud we are looking for dH over dt. Alright, kita nak tengok dH over dt. So sebelum kita menjawab soalan ni, kita keluarkan dulu information yang ada dalam soalan ni. Yang pertama sekali, kita ada radius which is r is equals to 2 meter, and it is also provided a volume, dv dt. dv dt dekat sini iaitu 2 meter cube per minute. So dekat sini kita keluarkan information. So we have dv, sorry, so kita ada dv dt, sorry again, kita ada dv dt which is equals to 2 meter cube per minute, and we have a radius of 2 meter. So in order to find dH dt, saya akan gunakan kaedah chain rule. Chain rule of dv over dt. Alright, so saya akan gunakan kaedah chain rule untuk dv over dt, di mana untuk dapatkan dv dt, so we supposed to have dv over dh time dh over dt. So here, so we already have a value for dv dt, and now we're looking for dH dt. So kita nak kena dapatkan lagi satu, iaitu dv over dh. So in order to find dv over dh, saya akan gunakan formula volume dekat sini, dv, which is v equals to pi r squared h. So kita nak kena differentiate v with respect to h accordingly. So here kita akan differentiate dv with respect to h. So here we have so pi r squared to since we differentiate v with respect to h, then pi and r squared we need to consider as a constant. So kita nak kena consider dia sebagai constant. So bila constant, kita boleh keluarkan daripada process of derivative. And then kita differentiate with respect to h, which is h. Alright, then this is equivalent to pi r squared times 1. Then kita ada nilai r dekat sini, which is r is equals to 2. Therefore our dv dh is equals to 4 pi. So now we have a value of dv over dh. Now we compute the value accordingly. So kita akan dapat 2 sama dengan 4 pi times with dh over dt. So now we just need to simplify dh dt in terms of, jadi kita akan dapat dh over dt is equals to 2 over 4 pi. 2 over 4 pi. Since dekat sini dia pakai unit meter, so kita akan pakai meter per minute. Alright, so kita simplify. Sorry, so we need to simplify this as 1 over 2 pi meter per minute. So this will be a final answer. So yang ini adalah untuk example 1. So now we move on to example 2. Example 2, a spherical balloon is inflated with air at a rate of 200 centimeter cube per second. Find the rate of change of the radius of the balloon when the radius is 6 cm. So now kita nak dapatkan rate of change of radius. So bila kita nak tengok rate of change of radius, so yang berubah, kadar perubahan dekat sini kita nak tengok adalah radius. So therefore kita nak cari apa dekat sini, dr over dt. So kita nak tengok dr dt. So again, so this is spherical. So bila dia spherical ni mengembang, so kadar radius ni juga akan berubah. So dekat sini kita akan keluarkan dulu information yang kita ada. So we have dvdt. Dvdt is given. Okay, dvdt is given dekat sini, which is 200 cm cube per second. So we have our dv over dt, which is equals to 200 cm cube per second, dan kita ada nilai R, which is 6 cm. Okay, so sama juga dekat sini, kita akan apply konsep rate of change. Kita akan apply konsep chain rule. Okay, chain rule. Okay, chain rule of dv over dt. Okay, which is equals to dv over in this case dv over dr times with dr over dt. Okay, so before that we also need to know what is the formula volume of spherical. So the formula for volume of spherical is V is equals to 4 over 3 pi r cube. Okay, sorry, so this is cube. Okay, so as usual, this one is given to us, dvdt. Yang ini yang kita nak kena cari, yang ini yang kita nak jawapan dia. Okay, yang ni kita nak kena cari dengan menggunakan formula of volume. Okay, dv over dr. So now if you can see the formula for volume here, we have 4 over 3 pi r cube. So kita boleh differentiate v with respect to r. We have an unknown r, so therefore this 4 over 3 pi kita nak kena consider dia sebagai constant. Alright, now kita dapatkan dv over dr. Okay, dekat sini kita akan ada 4 over 3 pi. So this is 2 is a constant, kita keluarkan. So r cube kita differentiate, kita akan dapat 3r squared. Okay, now we simplify. So this 3 we can simplify, then we have 4 pi r squared. Okay, as dv over dr. So remember, we have a value of r, okay, which is equals to 6. Then we have our dv dr is equals to 4 pi times with 6 squared. Okay, which is equals to 144 pi. Okay, 144 pi. Then after we got dv dt, then we can compute into chain rule accordingly. So this is our chain rule. Alright, and we have dv dt is 200 is equals to dv over dr. So we have 144 pi times with dr over dt. Then after we simplify, we will get dr over dt is equals to 200 over 144 pi. Okay, so this time our unit in cm, so kita tulis cm per second. Okay, then kita simplifykan 200 over 144. Okay, 200 over 144. Okay, after we simplify, right, so kita simplifykan 200 over 144, kita akan dapat 25 over 18. So therefore our dr dt is equals to 25 over 18 pi cm per second. Right? Okay, so this is actually for example 2. Now we move to example 3, the last one. Okay, the last one. Okay, so we have a thin round metal is being heated. The area of round metal is increasing at the rate of 0.5 cm. So kita highlight ini. Okay, the area of the round metal is increasing at 0.5. So we have our first information, which is dA over dt is equals to 0.5 cm per second, and find the rate of change of the radius when the radius is 2 cm. So we have r is equals to 2. Now we need to know rate of change of the radius. So let's say that this is actually our radius that we're looking for. So benda ni bila dia dipanaskan, dia mengembang, so the radius will be changing as well. So kita nak dapatkan dr over dt here. So again, we are going to use a chain rule. Okay, chain rule of dA dt. So saya akan tulis dA over dt is equals to dA over dr times dr over dt. Okay, so this is actually we are looking for dr dt. So dA dt is given. So yang ni kita nak kena cari dengan menggunakan formula of area of a circle. So area formula area of a circle, which is equals to pi r squared. Okay, pi r squared. So now we need to differentiate a with respect to r as usual. Kita akan differentiate a with respect to r, which is equals to 2 pi r. Okay, then we have our r is equals to 2. Therefore kita akan ada dA dr, dA over dr is equals to 4 pi. Okay, then we plug in. Okay, then kita ada dA dt, which is 0.5. Saya tukar kepada pecahan. 0.5 is equals to half is equals to dA over dr is 4 pi times with dr over dt. So therefore as simplify, kita akan dapat nilai dr over dt, which is equals to 1 over 8 pi. So unit dia dekat sini adalah cm per second. So this will be a final answer.